Hello, hello everybody, and welcome to a new webinar from Velp Scientifica. Today, with the expert Roberto, we will see how to elevate your research with the all-in-one CHNS elemental analyzer. We will start with an introduction to elemental analysis. Then I will leave the word to Roberto Marconi, our product manager for elemental analysis, and with him we will see how to prepare the sample, the principle of operation, so how our EMA 502 works. We will see how to set up the analysis, and we will see the range of application in which our EMA 502 can be useful for your laboratory. And then we will finish the session with the Q&A session. So please write down your question using the chat box you have on the right of your screen, and we will answer at the end of this webinar. But before starting, let me introduce myself. I'm Mattia Mura, Velp Marketing and Communication Specialist here at Velp. So let's start understanding what elemental analysis means. So elemental analysis aims to quantitatively determine the composition of an organic compound through the oxidation of elements within the sample. Our elemental analyzers, therefore, are based on a high temperature catalytic combustion technology that has proved to deliver precise, reliable, and matrix-independent results in just a few minutes. And we will see later with Roberto that the samples are introduced into the combustion furnace at high temperature, generally above 1000 degrees Celsius, in the presence of a catalyst and in excess of the pure oxygen gas, in order to convert the elemental components into gaseous oxidation products, which then are quantitatively determined by the means of a detector, in this case of the EMA 502, the TCD, thermal conductivity detector. So, as you can see from the picture, this is our portfolio of elemental analyzers. Starting from the right, we can see that we have the NDA 702 for the analysis of nitrogen and protein following the Dumas combustion method. While in the middle, we can see the CN802 for the determination of carbon and nitrogen. Then on the left, we have our EMA 502, that is today's focus, that is Velp all-in-one solution for the determination of carbon, hydrogen, nitrogen, sulfur, and oxygen. So thanks to the high sensitivity, low operating costs, and easy design and high sample throughput, today we can cover a large variety of applications. In fact, the EMA 502 can be applied in industrial sectors such as pharmaceutical, chemical, environmental, agricultural, material characterization, and so on. And it lets the operator determine, in accordance with official reference method, as we said before, the carbon, hydrogen, nitrogen, sulfur, and oxygen content inside the sample. But which are the main features of our EMA 502 elemental analyzer? First of all, we are talking about an all-in-one solution, so it does not require any add-ons or additional external modules. It is possible to easily perform CHNS analysis and then switch to oxygen mode in few seconds. Then, thanks to the gas chromatography column, it ensures an homogeneous and modular temperature, leading to a complete separation of all the elements for the final detection by, as we said before, the TCD detector, granting accurate and reproducible results. Then the EMA 502 is designed to work unattended with a fast and easy routine maintenance. Indeed, it is possible to analyze both solids and liquid samples and process up to 170 samples in a row with the electronic autosampler. All of it with matrix independent results, as we will see later with Roberto. Then the laboratory has the versatility to choose between helium and argon as carrier gas. We will see later the benefit of using one instead of the other. And then we have the possibility to easily manage the instruments and set all the parameters with the user-friendly EMAsoft software that provides all the information, data, and results at a glance. And last but not least, as you can see from the picture, thanks to our Velp Hermes cloud platform, it is possible to real-time monitoring and managing the EMA anytime, anywhere, using tablet, smartphone, and PC. Thank you for the attention. I leave the stage to Roberto, and with him, we will go through all the overview regarding our EMA 502 element analyzer. Thank you.
Hello everyone, let's start introducing the sample preparation. Sample preparation requires some care and attention since very small quantities are typically used. EMA 502 is a microanalyzer and requires few milligrams of organic sample, typically from 2 to 10 milligrams, but also can measure up to 100 milligrams for sample with low carbon content. Solid samples should be ground to fineness of 0.5 millimeter to obtain a homogeneous sample. So the degree of homogeneity of the sample is one of the most important factors which affects the quality of the analysis results. Moreover, it is important to mention that when weighing milligrams of samples, a microbalance is recommended. So also the balance can influence the measuring accuracy. Sample preparation of solid samples is easy. You have to add the sample into a tin foil with a conical shape, then close the foil over the sample with the aid of tweezers and put it into the autosampler that can have 30 positions up to 117 positions, and the autosampler is totally electric. The correct sample weight depends on the elemental content of the sample to be determined. So in microanalysis, the sample weight should be between 2 to 5 milligrams in most cases. So higher is the amount of carbon in the sample, lower is the sample weight. But on the other side, in some soils, for instance, with carbon content around 1%, it is possible to reach, for instance, sample weight of 90 milligrams. Note that in the combustion zone, the oxidation of the wrapping material, the tin foil here, generate a short time temperature up to 1800 degrees, so-called flash combustion. And this high temperature help to achieve a complete combustion of the sample. The preparation of liquid samples is performed using tin capsules. So it's possible to direct add the sample liquid with the syringe inside the capsules and then close it with the special device, a closing device for tin foil caps. As an alternative, we can use also the super absorbent powder that is helped to solidify the sample, facilitating the closure of the tin foil without any loss of sample. So let's go through the principle of operation. The sample first is transferred to a purge chamber into the sampler, where a flow of carrier gas that can be helium or argon purge the nitrogen before entering in the combustion chamber. Then the solid sample drop down in the combustion tubes in the condition of high temperature over 1000 degrees, in the presence of catalyst and in excess of pure oxygen, and here the combustion takes place. And all the elemental components of the sample are quantitatively converted into the gaseous oxidation products. While in the bottom part of the tubes, a formulation of active copper powder placed in the lower part of the reactor complete the process by reducing nitrogen oxide into molecular nitrogen. So here we have the formation of the reference gas we want to measure, that are CO2 for carbon, water for hydrogen, SO2 for sulfur, and molecular nitrogen for nitrogen. And then the gas stream reach the gas chromatographic column, which ensure homogeneous and complete separation of the elements prior to the final detection by the thermoconductivity detector. So all the process take about 12 minutes. And looking at the software screen, you can access to the live formation of the peaks for the complete CHNS determination with a real-time graph displaying all the functionality and all the parameters of the analysis. The EMA 502 used just one reactor to perform both the combustion and the reduction. So you can see in the image, on the top, there is the active part, the catalysts are tungsten oxide, while in the bottom part, there is the active copper to perform the reduction. We also provide pre-packed reactor, and in case you need to measure samples that produce a lot of ashes, such as sediments, such as soil, you can also use an ash collector inside the combustion tubes. If you want to switch from the CHNS mode to oxygen mode, it's very, very fast because EMA 502 is an all-in-one compact solution. So you do not require any add-on modules to switch from CHNS to oxygen, but you can perform it in very few minutes. The first operation is to change the reactor from the combustion tubes to a pyrolysis tube. Then you have to change a connection in the front panel and replace the GC column. The principle of operation is really similar to the classic CHNS mode, with the difference that for oxygen determination, we have to work without oxygen, that is called pyrolysis. So the sample is transferred to a purge chamber in the autosampler, where first a carrier gas purges the sample, and then the sample drops down into the pyrolysis tubes, where oxygen of the sample is quantitatively converted into carbon monoxide. Then the gas stream reaches first a chemical trap that is used to trap acidic pyrolysis products, and then into a GC separation column that helps to separate the carbon monoxide from other gas, other impurities. And then there is the detection by the same TCD detector. So the oxygen determination takes about 6 minutes. The reactor for oxygen is again a quartz tubes where the active part is a nickel wool and nickel carbon wool. Also in this case, we can provide also pre-packed reactor, and you can choose if you want to use an ash collector inside the combustion tubes in case you have to measure a lot of samples that produce a lot of ashes. So how to set up the analysis? Preparing for analysis is actually very easy. All the functionality of the instruments are managed by the software called EmaSoft that comes with a user-friendly interface that displays all the relevant information at a glance. This year also, the software is also compliant to the 24 CFR Part 11 that are mainly developed for companies in the pharma that requires to be compliant with the regulation, such as the FDA's. So before starting analysis, some of the columns in this database of the software must be filled and are mandatory. The first is, of course, sample name. The second is sample type, because sample can be managed by the software as checkup samples that are used to condition the instruments, for instance, in the morning before starting sample analysis, or can be calibration standard, or simply as a real sample. Third, sample weight. Sample weight can be entered in the main window manually or using a balance, so it's possible to transfer the weight from the balance to the PC. The fourth is the methods. The methods determines the analysis parameter. We will see in details what is a method. It is very interesting, but methods are used in few words to calculate the time the instrument takes to load the oxygen necessary for sample total combustion. And last, you have to select the proper calibration curves used for the calculation. So all other database columns are filled automatically by the instruments at the end of the analysis. It is interesting to see in details what is a method. Methods automatically defines the optimal oxygen dosing for the complete combustion of the sample, depending on sample matrix and sample weight. So here you can see a screen of the software. So you can see we have a full huge library of predefined methods. So you can also create your own methods and customize methods. So the methods determines the volume of oxygen necessary to achieve the complete combustion, depending on the sample nature. So you can choose, for instance, the flow, and on the sample weight. So you can define the volume of oxygen dose per milligram of sample. So all the process then is automatic. So you can just select the methods and the software automatically will dose the optimal amount of oxygen to achieve the complete combustion. Different calibration curves can be created and managed in order to optimize the analysis of the sample. It is not necessary, however, to calibrate the unit on a daily basis because elemental analysis provide matrix independent results. So with the same calibration, it is possible to measure any kind of sample metrics. Here there is an example. So this table comes from a very common standard. As you can see, you can calibrate the unit with any kind of pure chemicals that have a content of carbon, hydrogen, nitrogen, or sulfur. Of course, you can also buy your own standard, create a new standard, and use it to calibrate the instruments or to check the calibration of the instruments. And then, in the software screen, at the end of the analysis, you will see the results as a percentage of nitrogen, of carbon, of hydrogen, and sulfur. And as an alternative, if you are working in the pyrolysis mode for oxygen, you can, of course, obtain the results as a percentage of the oxygen in your sample. The EmaSoft is a truly modern and effective software with many features. Just to mention library of pre-installed methods with the creation of customized one. There is automatic leak test, auto sleep and wake up, the maintenance menu that sends alerts when the reactor is almost exhaust, and also statistical calculation. But a real advantage of the EMA 502 is the Velp cloud platform called Hermes. Just to mention a couple of advantages of this platform. The first is for sure to simplify the service. So problems, the diagnosis can be very fast because it's very easy to establish a remote connection with the computer and check the basic parameters even the days before the issues. So it's very easy for us to give support to our customer. And the second is possible to control the instruments in real time with a tablet or with a smartphone, and can be very convenient, for instance, to perform some operation remotely, so you can control the software remotely, or for instance, to check live the results or download a report. Now let's go through the application of our EMA 502. One of the most common application is petrochemical industry. So elemental analysis is established as a standard technique for fuel characterization. For instance, the hydrogen determination is very important for determination of the net calorific value of coal, for instance. But other elements are very important. For instance, sulfur determines the market price of coal. So according to standard, typically ASTM or ISO standard, coal, coke, mineral oil, crude oil, and DV oil are very common samples measured with our EMA 502 elemental analyzer. For instance, sample with high carbon content, such as coal, that can have up to 90% of carbon, needs more oxygen to reach complete combustion. And sometimes we add special additives, such as vanadium pentoxide, to improve recoveries. So in this table, you can see the results obtained with coal samples. You can see a carbon content of from 70 up to 90%. So there is a method pre-installed in the instruments called coal that it's able to automatically dose more oxygen when measuring this type of samples. A second field of application are biomass. And biomass, especially when are considered as biofuel to be burned in power plant to generate electricity, or for instance, in cement plant. So according to ISO, here you can see a very common ISO for the determination of elemental content in solid biofuels. It's important to measure hydrogen for the calculation of the net calorific value, for instance, or also nitrogen and carbon for determination of gas emission in the atmosphere. Here you can see an example of very common biomass, for instance, dried seed and peel. We measure wood chip, very common palm oil, and it's very easy to obtain very accurate results of a CHNS determination in biomass. Here in this table is reported also the gross calorific value of this kind of biomass, that is the energy released as heat when a substance, when biomass undergoes complete combustion, and we can perform the correction, especially with the value of hydrogen, to obtain the net calorific value. That is the energy value that can actually be used in the combustion process. Another important application are the measurements of solid and liquid waste. waste-to-energy plants burn municipal waste, typically called garbage or trash, to produce electricity. So solid waste and liquid waste are energy-rich samples. So according to ISO, it's very common to perform a full CHNS determination. Hydrogen is especially useful for the calculation of the net calorific value for power plant, and sulfur, carbon, and nitrogen to determine the emission of this gas in the atmosphere. Here we reported an example of different kind of solid and liquid waste. So we measure sewage sludge, we can measure mineral oils, foundry sand and soil, and it is very important to note, for instance, in this table, that it's possible with the same calibration to measure sample with very different content of, for instance, carbon. Sample A have up to 87% of carbon, and sample C have lower than 1%. With the same unit, with the same calibration, it's possible to measure very different sample metrics, one after another. Elemental analyzers are very important also for material characterization. So determination of the CHNS and oxygen also, in this case, are very important for the product quality control of many finished products, such as polymer, like rubber, polyolefins, Teflon, Viton. We have customers that measure also high-tech materials like glass fibers and graphite. And also it's very important for the synthesis products. So the CHNSO characterization, it's very, very important to measure pure chemicals after organic and inorganic synthesis. In this example, we measure samples of Viton. Viton is a synthetic rubber, is a fluoropolymer resistant to extreme temperature, very common in O-rings, in gaskets, and the CHNS and oxygen determination by pyrolysis, it's very, very common for the characterization of this family of material. Viton contains also a lot of fluorine. Fluorine is an aggressive element, so we can add a special additive called fluorine absorber that can be weighted with the sample and help to protect the instruments from aggressive fluorine. Elemental analysis is also used in the pharmaceutical industry in both the production but also in the quality control process. So in this case, we provide also the EQ, OQ, and the PQ, the performance qualification documentation, and also a software compliant to the 21 CFR Part 11. When measuring pharmaceutical, pure chemical, it's very, very easy to obtain excellent reproducibility with no memory effect. So in this table, you can see very nice and accurate results of pure chemicals. Also, an important application field is agriculture. For instance, fertilizer, because CHNS elemental composition of fertilizer is used by the manufacturer for controlling the raw material, but also the finished product. And also we have several customers that use our CHNS analyzer to carry out agronomic research. For instance, to make better nutrients management decisions, but also to optimize the fertilizer use to obtain minimized costs. In this example, we reported the analysis of very common inorganic fertilizer and different factory-made organic fertilizer. we just published an interesting application note. So we recommend you to download from our website. And there is a full description of the methods to measure inorganic and organic fertilizer. Because typically, inorganic fertilizer can show a difficult combustion behavior due to the lack of organic material inside. So looking at this application note, you can really learn how we succeed to measure this kind of samples. For agriculture and the environment, also the study of the organic matter is of great importance for the new land management techniques. There are very common parameters, such as the ratio between carbon and nitrogen, that is typically used to study the balance of the nutrients in the organic matter. But also, total organic carbon analysis is very important, because the determination of organic carbon plays a fundamental role in the characterization of soils and sediments, as its presence or absence can significantly influence the finite characteristics of a soil, such as the structure of a soil, the water retention, the nutrients availability. So in this last example, we measure different kinds of soil and sediments, and we measure, of course, total carbon, total nitrogen. The instrument is able to determine the ratio between carbon and nitrogen, and of course, the total organic carbon determination, that is TOC. We measure soil, but of course, we can measure any kind of sample in this field. That can be soil, can be sediments, can be clay, plant, leaves, and more recently, biochar, for instance. Nice. Thanks for attending this webinar. Now I call here with me Mattia for answering some of the questions we collect during the session.
Thank you, Roberto. We received some of the questions, and the first one that we received and we want to ask is, which gases are required to start up the analysis?
Okay, the instruments as a utilities needs two gases. The first is the oxidizing gas, so the combustion gas, that is oxygen. And the second is a carrier gas that can be typically helium, but also argon as an alternative. The difference between helium and argon is, of course, that argon allow to save money, because it's far cheaper compared to helium. But you must be aware that when using argon, you lose a bit the sensitivity. It's very classic, because argon is a different gas, and so the best accuracy can be obtained by helium. And argon, you can measure just CHN mode, so you cannot measure sulfur when using argon. It is also important to mention that argon, that the instruments when it is installed, you can choose between helium and argon without any change in the instruments. So at any time, you can decide which gas you want to use. Of course, you have to recalibrate the unit when you change the gas.
Thank you. The second one is, what consumables are involved and which of them are included in the supply?
Okay, the elemental analyzer comes typically with a supply of about 1,000 analyses. So inside the supply of the instruments, there are all the parts that you need to perform the first 1,000 analyses. So with the instruments, there is, of course, the autosampler, there is the software, there is the cable to connect, for instance, a balance, but there is also a supply of consumables such as combustion tubes, the catalyst, and also a supply of all the things you need to perform the first routine maintenance. So a supply of O-rings, a supply of seals, and so on. so you don't need anything else for the first 1000 analysis, I would say.
Okay, thank you very much, Roberto. We received many questions, but we are running out of time. So thank you very much for the attention and stay tuned for our next webinar. Thank you very much.
Thanks a lot.